So maybe, thanks for again joining us,
Oh,
Sundeep.
that's
Maybe
fine.
you could begin by telling us a little bit about who you are.
Okay, I'm a fourth year PhD student doing my research at Wayne State University. My advisor is Dr. Leela Rava. Yeah, that's fine.
So tell us a little bit about Micro Buoy and what you guys are working on.
Okay, so we're a group of 4 people who started Micro Buoy back in 2015. We had an initial idea of how do we detect these contaminants from water, because there are many awareness groups that are already there spreading awareness, but it's really hard to get the right amount of contamination in these lakes or rivers.
Hmm.
So that was our key goal, and that's what driven us to this sort of experience. And
So what kind of contaminants are you talking about in particular?
okay, so we have different variations of sensors,
Hmm.
like which detect nutrients, heavy metals from the water.
Mm-hmm.
So as you might be knowing, these heavy metals and nutrients are run off from the farms. So when there's huge amount of rainfall, all these get flooded and they get into the lakes. That's what
Mhm.
is the usual process of phenomenon that's going on.
Mhm.
Yeah.
Do you remember your pitch? Can I ask you to give me your little 2 minute or 3 minute pitch?
Yeah, it was pretty simple. It was pretty simple. We are not creating an awareness. We started like that. We're not creating awareness. We're not telling us to stop it right now, but we're just telling you what is the exact amount of contamination.
Hmm.
Because there aren't in much technology or sensors that are really there in the lakes right now, even right now,
Mhm.
that could exactly tell you what is happening. So that's bad.
Mhm.
If you know what's happening, you can start thinking on how to reduce that, right?
Mhm. So tell us a little bit about the buoys themselves. Like, how small are they? Who uses them? What's your target? So, give me the whole spiel, the whole
Okay.
pitch.
We had a multi-purpose. We have multi-purpose buoys actually. We have two different variants in that. One is a handheld buoy that you just lift and put it in a swimming pool, or just put it in a small bucket of water, and it'll start detecting the contaminants inside the water.
Mhm.
This is just for like fast check of what is happening. You can just go to the shore of the lake and drop it. After a few minutes, you can just take it out instead of taking a sample of water,
Mhm.
taking it to the lab. So this is instant,
Mhm.
and you can call it instant detection.
Hmm.
But the second variant is the full-fledged model we have, which has like solar sensors, solar chargers in there. We have like high capacity batteries that could last longer,
Mhm.
because once you have these buoys deployed in the lakes, they should even last for like year and a half, so that you have a continuous amount of data that's coming out from the lakes,
Mhm.
so they can monitor all the climatic change and how is it affecting over the years.
Mhm.
So yeah, we have two different types of variants.
Mhm.
Yeah.
So, so you were talking primarily of metals and minerals,
Mm-hmm.
right? Are we? So we were just changing batteries, for instance, right now. So we're
Okay.
talking about, say, if we dump batteries in the water system,
Mm-hmm.
are we talking about that kind of contamination, or what? What are some of the sources of some of this contamination?
Okay. Like let's take an example of Lake Erie, which
Mm-hmm.
is like mostly like 60 to 70% surrounded by farmlands,
Mm-hmm.
or has a radius of like 20 miles, which has farmlands there,
Mm-hmm.
farm fields. So when there's heavy rainfall, sorry, to have a better crop or harvest, farmers use pesticides or like fertilizers on a regular basis.
Mm-hmm.
That's how they get good yield, right?
Mm-hmm.
That's understood. But if they use a certain excess amount of these fertilizers or pesticides,
Mm-hmm.
all the soil is like enriched with
Mhm.
all these phosphorus, lead,
Mm-hmm.
which over time gets accumulated as a layer on layer on layer.
Mm-hmm.
Even though if you like plow it and put a layer inside, it's still going to be on the top layer. So if it starts raining, these minerals come out. They get lifted up because these are like not heavy in weight. They
Mm-hmm.
just get lifted up with water,
Mm-hmm.
move along the streams, like get into the drainage, or like start moving along where there's a path, and they get into the lakes.
Mm-hmm. So it's primarily agricultural runoff.
Yeah,
Metals and
agricultural,
minerals.
and I can say it's mostly agricultural. The study which we took, we started looking at the data. It
Mhm.
all showed us like How did I say it's agricultural is because when it rains, you can see there's a lot of phosphorus coming into the lake all at a time. So where does all of that come? It's not from like carbon emission or anywhere. It's just from the lakes, from the farm fields.
Would the buoys work also for industrial waste detection?
Yeah, it depends. Like for example, industrial wastes are always heavy metals like lead. Okay, which is very hard to detect. That's a huge problem with lead. So we worked on a sensor that can detect lead, but when it comes to resolution, you have to go like parts per million, parts per billion. So then you have a question like how accurate is our sensor? So we are right now working on how do we get a good resolution or like get a good spectra of these lead sensors. So we have the capability to like integrate this lead sensor into the buoy as well. Yeah.
Who will be the target of your products?
Like everyone, to be frank, everyone to be frank, because everywhere there's like water bodies. We are surrounded by water bodies, right? And that's a good thing. So, but we're not sure. We can't just take a glass of water and why don't we drink it from the lake exactly? We don't, right? Because it should be like that. If it's nature, it's like it should be pure, right? But it doesn't. It should be. Hopefully, because all the lakes and rivers have this ecosystem, like the fish or the aquatic and the marine life inside. Usually cleanse the water, like that's the ecosystem, right? If the ecosystem goes away, the water is going to get contaminated.
Are utility companies, water utility companies at all, do they figure in your thinking in terms of target audience or target customer?
Oh yeah. They come into our market actually. We come into their market actually. But to be frank, what we are working on is recently you might be hearing this like last year, I guess. There was this shutdown of water inside the schools, the high schools. They shut down the water. Still going on, right? They had this lead contamination, right? They found lead. So what we were thinking is, why don't we have this lead sensor inside the water fountains where students or children have access to drinking water? Because once you have a lead, if it just blinks a LED,
you can do that. So it's not just the buoy. You can put it not just in the lake.
Because the sensor comes in like an inch and a half, so it's very compact.
Okay.
So that's the key thing. You had to be compact. That's be resolution. These are all the key things. So we put in mind that this has to be compact.
Okay.
So it just has to come in contact with a few microliters of water maybe, and it just like bingo, just catches the lead.
So what happened? Did you guys do that?
Oh, we're working on that. The main hurdle or the obstruction we have right now is like we are like full-time PhD students.
Right.
We work on finishing our dissertations all the time. Try to push that up. So that's a catch we have, time constraint and how many people are working at the same thing at the same time. So students come. Actually, when we started we were like 4. Right now I'm working alone because the other students have other interns or like training going on at different places of the country, so they're not here.
Have you guys talked about this at all with anyone at DPS, Detroit Public Schools, or the city, or maybe any of the nonprofit groups or the community organizers on the ground who are working on these issues?
We spoke with the Detroit Water Company, DTE, that supplies the water to like
DWSD?
DWSD, to the Midtown and the Detroit region, like back in way 2014, because because we had to know what amount of water they give and how do they even test it.
Right.
So they had good intentions of taking our sensors and testing it, but as I said before, it's still in the process where we want to figure out this is like there's no error inside the sensor itself, because this is lives we're talking, right? If the sensor tells you that no, there's no lead, and if for example there's lead present in the water, oh yeah, that's bad. I don't want that. So lead is a very tricky thing. Phosphorus, nitrogen, these are all like good. We have literature, we have people who've already designed, but lead is something.
So Are you a registered LLC right now, or not, a different kind of company?
I think it's a Leicester LLC, yeah.
Okay.
Limited liability. Yeah.
So, why water? Why here? I guess when you started working on this project, were you paying attention? Was this really happening all in the backdrop of what in Flint, for instance, or were you hearing about any sorts of stories or events in Detroit?
Mm-hmm.
What was really going through all of your heads when you were starting to work on this project?
Like growing up, I was born in India,
Mm-hmm.
so I had my formal education done there. Growing up there, like it's the same problem we have here in the Michigan, like United States. All the lakes and rivers are facing this contamination, right? India has also many rivers; they're also facing the same
Mm-hmm.
sort of issues. So back there, we thought of like working on a project, a key project, but I had to do my higher education. I came to United States. Over here, when I started working on my research, so we had a task like, okay, we can design a sensor or we can come up with a thesis, but what's after that? It's just
Mm-hmm.
going to be a recorded document and there's nothing going to be happening.
Mm-hmm.
So we didn't think that way. We thought like, okay, let's come up with a device and let's make the science around that like really strong.
Mm-hmm.
So, but that's what we did. So, what we picked up water because water is essence of every human life.
Mm-hmm.
We can't even imagine a day without water, right? So that's what like really.
Mm-hmm.
And all of our teammates, the four people which I'm talking about, we all had the same motto when we had the same motto, like we shared the same thoughts, and we saw that okay, what if we had these sensors
Mm-hmm.
before even somebody did it, and we wouldn't have the Flint crisis, right?
Mm-hmm.
So many other things like that. So all these are like influences a lot. Okay, this is where we need to like really move.
Mm-hmm.
Yeah.
Do you find um, do you find that you've been paying a little bit more attention to some of the news and concerns related to water in this region in the city since you started working on this project?
Yeah, I started working on this project in 14. Yeah, like I'm trying to like try to be updated like whenever I often or like whenever I can.
Mm-hmm.
But yeah, but don't get the whole picture of it
Right.
because I know the lake is contaminated, but I don't know what is the exact value.
Right.
So these are some details which researchers can appreciate or like go through.
Well, 2014 was really when the water shutoffs in Detroit really peaked.
Yeah, yeah.
Really around that summer. And that was really also when I started really following that crisis for this project. And it's interesting that it's now 2019.
5 years down the line.
Right, and the shutoffs are still going on, but at the same time, you also have, I think, way more information coming about how it's connected to failing infrastructures on the one hand, and continued industrial waste and agricultural waste on the other hand, contamination, and how all of these issues are really connected to each other. So, so let's talk about Erie Hack. How did you find out about it? How did you think that you'd like to participate in it? So tell us really all about the background about that.
Okay, actually, there's an interesting story how it all started. We were just like sitting in the lab and working on the project for the day, and our advisor, Dr. Leela Arava, emailed us saying that there is a small meetup going on like river contamination. Why don't you guys go and check out? It's like we were like, oh no, we're done. It was already 5 o'clock in the afternoon, so evening. So we thought like, no, we're not going there. So we read a small a note underneath the email saying that there was a free pizza. So I was like, okay, we didn't have a lunch, so why don't we go and grab a slice of pizza?
That's universal in grad school. Come on, free pizza, everyone
So we
knows.
walked there all the way to Tech Town, and we just went inside. We didn't have an idea what was the agenda for the talk or like who's going to present the work or what was going on. But when we started like interacting after a few minutes, we felt that, oh yeah, this is what we're doing. This is where we should be, like talking about our product. So we met Brian first time.
What was that initial gathering or meeting like? Who was there in the room?
It was mostly like a group of maybe 20-25 people, a small group. There was Max, Brian, there was Paul from Tech Town, and yeah, it was me, the other teammate I had, and a few other people. I don't remember the exact names right now, but they were all there for the same cause. They all had the same idea. They understood what was going on. They exactly knew what they need. We had a solution, but we didn't know where we could put that.
Right.
Okay, as I said you before, we had a sensor, but we didn't have a buoy ready by then. So they said they gave us a picture. So they gave us a direction actually. So how we can push our product. So that's where everything started. Yeah.
So this was the inaugural, the first Erie Hack, right?
Oh yeah, the first Erie Hack. Yeah, the first, even they didn't have a set of rules or instructions or like what is going to happen, when will be semifinals, what was the duration, team members, like it was really the first, like they baked it out like as they went. Yeah.
So tell us a little bit about how, being a part of that process, because, it's not quite as simple as just going to an initial meeting and then, immediately pitching. We know that there's a series of long drawn out meetings, discussions, refining your work, refining your project. So tell us a little bit about that process where how you and your teammates over time, I guess, refined what you wanted to do and how and what you wanted to create.
Okay, we didn't pitch like right after that first meet. There were a set of like 6 or like 5 meets that we attended. We actually used to network with other people all the time. So everybody was a knowledge base for us. So everybody was giving out some sort of an input that was used in our pitch, to be frank, because they traveled like other universities. They read other articles on what is happening. So they had a good vision of what they are expecting from these meetings. So yeah, so we had a lot of input from everybody who was there. Everybody who was there in the meetings. So later on, we put together all these ideas, and that's it.
So who were some of the mentors that you were talking with during this entire duration?
It was not actually mentors actually, because as you know, Brian, Paul, they just gave us like a few inputs or like how they can help us. But mentoring was I don't think we had a good like a group of mentors.
Oh really? Okay.
We had like friends, because as I said, we along with us we had other teams. They were also like friends or colleagues from other labs. We know each other like so.
I wonder if that might be something that they've therefore basically taken the initiative on, because this time around they were definitely plugging in plenty of mentors in technology, in law, in biology, social issues. Like they asked all of us to actually attend and be part of those discussions. And so we were definitely much more hands-on than what you described.
Yeah, because as I said you before, Erie Hack 1, they were like cooking things as they
Right.
like, okay, we need this, so let's put it. So somebody came and asked like, are we having some like a group of students with like eventually formed a group. They came up and asked like, do we have a mentor or a group session where we can go and ask a few questions, because it's very hard to find a few things online even now. So so then Brian and like Paul came up with ideas, but actually we had what do you say, a group of experts from I think GE and AT&T. They just gave us a few tips and ideas. They showed us what could be the possibilities, but we didn't eventually go that direction. So that was another thing. Yeah.
So, Usually, so in when we're working on projects and papers in academia, oftentimes the idea that you initially have is rarely the very same thing that is actually published or produced, right?
Absolutely agreed. Yeah.
So, can you maybe talk us through some of those twists when you had an idea, then how did you modify it, and then what was created, and then how did you further modify it? So maybe talk us through a little bit about through that journey.
Okay. Uh, so we had an idea that okay, when we started our research, we know that we had to do a sensor.
Mm-hmm.
Like so, we had different ways of doing that sensor. We could use light as a source of detection. We can use light to detect water contaminants. We could use electricity or current to detect.
Mm-hmm.
So we started with light because it was much easy because you can just take a water sample, put it in a spectrograph, take a spectra of that, and that could tell you. But in spectrograph, there's a lot of problem with the accuracy.
Mm.
So even this dust, spectrograph cannot differentiate between like aggregation,
Mm-hmm.
agglomerates, or like real contaminants. It's very hard to tell the difference. So that took us like 1.5 year of a like time, dead end.
Mm-hmm.
So then we started moving on to the other like interdigital electrode system,
Mm.
ID. They usually call this as ID. It's like well established and people know,
Mm-hmm.
and it's an industrial standard nowadays. So we thought, okay, why don't we go in this direction? And we did different variations. It took us like another year and a half to come up with the exact right design.
Mm-hmm.
Yeah. And when we designed that, we had a few things in mind.
Mm.
How do we make it for multi application purpose
Mm-hmm.
instead of just one purpose?
Mm-hmm.
Because if you have for one purpose, we can just finish our PhD and graduate, but that doesn't give any sort of usefulness to anyone.
Mm-hmm.
So then we thought, let's spend more time.
Mm.
So even our advisor, Dr. Leela, never like stopped us from exploring new ideas because that's how we learned
Mm-hmm.
about many things. Yeah.
Mm-hmm. So at what stage during this, I mean, because you just described almost like a 3-year
Mm-hmm.
journey, at what stage or at what point did the 5 months of Erie Hack come in?
Okay. The actual water sensors project started in our lab in 2013.
Mm.
I joined the lab in 14.
Mm-hmm.
So this Erie Hack was in 16.
Mm-hmm.
So people already had an idea that the optical sensors or the light sensors were not working.
Mm.
I came up and said that okay, this is a dead end. Let's move to the electrical sensors.
Mm-hmm.
So then, where I joined the lab, that's when we started moving to electrical sensors.
Mhm.
So that was the step there. And 2016 was where we had few initial like promising results
Mhm.
of our sensors, like they're detecting the contaminants in the lab,
Mm-hmm.
which was a huge success for us. Like we were very happy. We were like, okay, we're done.
Mm-hmm.
There's nothing else to do. Like we were so happy.
So by the time you went up to Erie Hack, did you have a prototype with you already by that time, or did you develop that prototype afterwards? Or are you still developing it up?
Like the sensor was ready,
Hmm.
but the buoy prototype was half ready.
Hmm.
Because being an electrical engineer, we knew we had like it just took us an hour and a half to make half the buoy.
Mm-hmm.
The other half is like mechanics. How do you make the buoy float?
Mm-hmm.
Because there's going to be wind and other forces like water, tide force, all them acting. So the center of gravity has to be managed so that it just doesn't flip.
Mm-hmm.
So these were certain things where it was not ready initially. So
Right.
we took a few more days, gave it a good thought, and
What did you end up doing with the money? The price
oh,
of
the
it?
money. To be frank, the money we got a check
'Cause it
of
was
40.
a lot, right?
It was $40,000. It was not a lot.
Not a lot, actually.
It was a lot for the beginning. Yeah, I agree that. But like we had some other what do you say sensors that we had to design, develop,
Mm-hmm.
which took like half the money out of that, and the other half we shared. We just took the we just shared the amount between us.
Mm-hmm.
So yeah.
So, thinking big picture,
Mm-hmm.
is there something or things that you have learned? What have you learned from the overall experience off Erie Hack?
It is a complete, what do you say, a bundle, a briefcase of things we learned. It was not just a single thing to start with. First, we saw what was really going on, because things were really bad at Flint and at Lake Erie and other lakes across the world. But why am I telling you about Erie is we were there looking at the algal blooms ourselves. We had a boat ride and we saw all those things. So that really changed our perspective of like looking at things, because we can't take things granted. This is nature we are talking about, so we don't want to take these things granted. And the second thing, we had a lot of hope. What I understood, because we're not sure when we started these sensors, or like we started the buoy, we didn't even think that would work. But with all the support and hope, like we had hope in us, like this is going to work, let's make it work. So I think we can come up with a solution in near future. I've seen other groups working on similar ideas, as you were telling me before we started talking. So I think I feel better after Erie Hack. Like I'm more aware that something is going on, but we have to make sure it goes in the right direction, because millions of dollars are being spent to clean up the lakes, rivers, and so yeah, a lot of awareness was there. I got a lot of hope that things going to get better, like the lakes eventually. Yeah, these were things I learned.
Have you, have your team members been working at all with the Office of Technology Transfer, or is that still too early at this point?
Maybe sometime this year. We already have certain meetings going on, because they heard about Erie Hack. They come meet us like once in a while, or we just. So they were interested with the technology, and they gave us like a few directions on how we could commercialize this or like patent this technology. We already have 2 patents back from 2017, I guess. After Erie Hack, we thought like, why don't we make this proprietary? Like, we don't want, because during the pitch, we opened all the secrets out. Like we were like, okay, this is how it's going to work. It was all there.
Right. So you open it up and now you have to like close it
Yeah.
back again in order to make it.
No, because we had to open it up because the judging committee or the people there were really excited. We didn't think about like the secrecy of that. We just thought like, okay, people should be aware, right? We worked, okay. People should be aware that, okay, this is going to really work. So in order to make them really get confidence, we had to go a step down, like really tell out the idea, and they're like, oh yeah, this works. So.
Were you surprised at how well you did and how far you went?
Actually, in the finals, we didn't think we were going to come first, because we were looking at all the pitches, and we were like, oh yeah, this is a good idea. Oh yeah, this is a good idea. None of them sounded or looked like a bad idea, because everyone has a motto that they have to put a certain mark or like put a protocol where they can really come up with a solution, right? So we were like, okay, all of them are good. So we didn't think that we're going to be first, like, so we were like shocked, really like amazed.